Hello, my name is Remy Goldberg, and here's my arc length project. For this project, I decided to find the length of a path in my neighborhood in Franklin Lakes, New Jersey. I use this path whenever I walk my dog or take a nice bike ride, so I thought it would be very interesting to find the length of this path. The path consists of two straight lines, one on Ginger Lane and one on Peachtree Lane. It also has two curves, one on Orchard Lane and one on Ginger Lane. The first curve I will be looking at is on Orchard Lane. I set the origin of the graph to be the intersection of Orchard Lane and Ginger Lane. I then found 4 other points along the path and plugged those into Desmos.com. Using regression, I found the cubic function you see on the left. I also found the equation for this cubic function that best fits this path, which is f of x equals negative 0.00114714 x cubed minus 0.184795 x squared minus 9.717226 x plus 29.0252. I then found f prime of x by finding the derivative of f of x. After this point, I plugged this into the arc length formula. The arc length formula is the definite integral of the square root of 1 plus f prime of x squared. The limits of integration for this calculation was negative 114 and 0. After plugging in f prime of x, I found that the length of this curve is 449.344842 feet. The second curve I am looking at is the parabola on Ginger Lane. I set the origin to be the vertex of this parabola. I then found the 2 endpoints of the parabola along with 2 other points lying on the parabola. After plugging these into Desmos.com, I found the best fitting quadratic formula and curve, which you can see right here. The equation for this parabola is g of x equals 0.0011484 x squared minus 0.0454751x plus 2.60876. I then found the derivative of this equation, which you can see as g prime of x, and plugged it into the arc length formula as well. For this calculation, my limits of integration were negative 196 and 403. After using a calculator, I found that this length was 652.426522 feet. Along with these 2 curves, I also have the 2 straight lines to account for. The red line on Peachtree Lane is 1,515 feet, and the green line on Ginger Lane is 1,007 feet. I used the Google Maps ruler application to find these lengths. So the total length of this entire path is the length of the first curve defined by f of x plus the length of the second curve defined by g of x plus the red line plus the green line. I plugged all the corresponding numbers in, which you can see right here, and then found that the total length of the path is 3,623.7714 feet, approximately equal to 0.6863 miles. According to Google Maps, this path is 0.692 miles, which is equal to 3,653 feet. Because these 2 numbers are approximately 30 feet within each other, I would say that my calculation is accurate. However, it would be predicted that the Google Maps number would be less than mine, but in this case, it's greater than instead. This is probably because there's measurement errors when using the Google Maps ruler application, so some of my measurements might not have been exact. Google Maps should have been smaller because the shortest distance between 2 points is a straight line, and because the Google Maps path is just a series of small straight lines, it should be shorter. But in any case, my number is relatively accurate due to the only 30 feet apart from each other. Well, overall, I was able to use calculus to find the length of the path in my neighborhood, and it shows how calculus can be applicable in everyday life. Thank you.